Lesson 10-7, Example 3. Our objective is learning to find the volume of rectangular prisms. And here we have a question. Suppose a tissue company ships 16 cubic boxes of tissue in each case, a case being the container. What are the possible dimensions for a case of tissue? Well, we know if there's 16 cubic boxes here, and we want to find out what are the possible dimensions. So that's our question here, possible dimensions. And we know that we have 16 cubic boxes. So our volume, if we have 16 cubic boxes, the entire space that it's going to take up is our volume, because volume is the amount of space that it takes up. So in this case, we already know that our volume is going to be 16 cubic units. Maybe our units are boxes. We could say, our units could be boxes there, so we have cubic units. So we need to figure out what are all these possible dimensions. Well, we know that volume equals the base times the height, or the length times the width. That might be a better way to think of it this way. Let's think of it as length times width times height. And on here, this is hard to think about when we don't have an actual object. So I'm going to use, for my strategy, I'm going to use objects. So I'm going to use some objects as my strategy, and I can actually just manipulate these around. And I want to be thinking about what are my length, my width, and my height. Those are the dimensions when they're talking about those things. So I'm actually going to set up a table here. Length times the length and the width and the height. If I multiply these together, I come up with that volume there. And I already know that the volume is going to be 16. So what I really want to know is what are the different possibilities these could be to get me to that 16. Well, if I just start moving some of these things around here, I need to get all these together. Well, let's just see kind of what they make up when I start moving them around. Get them in. Well, hey, here's one possibility. If I have all of them, I could just have a really long, narrow box. This may not be the best shipping idea in terms of the post office, but it is a possibility. Probably not likely possibility, but it's a possibility. So let's see here. I have a length of 1, 2, 3, 4, 5. Well, it's all of them, so that would be 16. A length of 16. I have a width of just 1 cube. Just this 1 cube right there. And then a height of also, that height there, if I look at it this way, that's a height of just 1 cube as well. And let me do a double check. 16 times 1 is 16. So that would come up with our correct volume. Let's see what else I could do moving these things around here. I could see if I push some of these down here. Oh, well, here we go. I could put them in this shape right here. It's a nice box-like shape. We have a length. Here we have, width. And we have a height. So let's see, our length here is 1, 2, 3, 4, 5, 6, 7, 8. We have a width here of 2, 1, 2. And we have a height still of just 1 cube. If I move it out of the way, there's no cubes beneath it. So it's just a height of 1 cube. And 8 times 2 is 16, and 16 times 1 is, well, also 16, so that works as a good double check there. Well, let's take, I think if I could take this, I'm going to break these apart. I should actually stick this right on top. Stick that right on top of the other one. And so let's see, let's look at our dimensions again here. We have a length of 1, 2, 3, 4. We have a width 1, 2. And this time, though, our height. If I move this one, here I have 1. If I move it up, there's another block right below it. If I move that one, that's no more. So there's a height of 2 blocks. It actually is too high. So let's do our double check here. 4 times 2 is 8, and 8 times 2 is 16 again. Well, What if let's say if I took this and I'm going to turn it this way. What if I did this? Would this be something with different dimensions? Let's take a look at it like this. I turn it up on its side. So now I have a length of 2. I have a width of 2, and I have a height of, let's take this way, I have 1, 2, 3, and there's a fourth one down there at the bottom. So I actually have a height of 4. Oh, there it goes, falling down. Well, these numbers look pretty familiar. They look very similar to what I just had up here. When we're multiplying things, we can actually multiply these in any order. I've just changed what the length, width, and height. So this is actually, even though this still comes out to be 16, these two are actually the same. I would think of those as the same dimensions because we have our same numbers coming up. 4, 2, and 2, 4, 2, and 2. That order, because I've just changed that object, I took it from one position and flipped it up, doesn't really actually change the overall dimensions of the package. It's just like taking a box and flipping it up on its end. It doesn't actually change the box. So let's see if I can come up with something that's actually different here. And there we go. Really nice square package for us. So let's say we have a length here of 4. We have a width of 4. We have a height of just 1. So let's see. Do I have any that already look like that? 4? No, I have 4s, but no 4 and 4. So I have 4 times 4 is 16, and 16 times 1 is 16. And in this particular case, these are all of our possible dimensions. So if I were to write this up as a solution, I would say our possible dimensions are 16 by 1 by 1, an 8 by 2 by 1, a 4 by 2 by 2, and these are the same, remember, so I'm only going to list that one once, and then a 4 by 4 by 1. This is actually this is all of our possible solutions, all the possible dimensions for that case of tissue.